Hey guys, welcome to FDM 3D printer tips and tricks. So in this video, we're going to be talking about some basic increase in performance as well as quality of prints for those higher end materials, PETG, ABS, ASA, polycarbonate, all the way up to ultimate peak. Obviously, you're going to need to go a little bit more than that for these different materials. So what you see here, this is a Creality enclosure. So basically, this is like a little tent body that you can buy, right? And then you put this cloth over it, and the inside is this aluminum film, and the outside is this cloth. Now, just a basic enclosure like this can drastically increase your 3D printing performance. So why is that? So this guy has zippers and it allows you to zip it up, and you see here you have plenty of room to have a spool hanging on top and feed it into the Bowden system here, for example, on the Ender 3. And it can easily double the inside temperature of the chamber. So why is that important? So when you're 3D printing these higher end materials such as PETG, polycarbonate, ABS polycarbonate mix, um, also ASA, is that they usually have very large thermal expansion coefficients. And if your bed cannot reach that high of temperature and you are printing large parts, what happens is in the middle of the part, you can start to have this curling action happen, this warping action. And the issue is that the taller the part gets, you're heating the material from the bottom, and then you are heating the material on the top because the nozzle is spitting out new material. But as you start to build up, the area in the middle is colder than everything else. And so things that are hot expand towards things that are cold. So basically, the top and the bottom will shrink towards each other, and that's where you'll get the curling on the edges. Now, you can minimize this with using good bed adhesives and also by using an enclosure such as this. So basically, what happens is the heated bed and the nozzle will heat up the chamber inside, and the zippers do a decent job of holding the temperature. I actually have a big version of this for my old Tronxy X5SA, which is a 500 by 500 by 500 millimeter enclosure. Or yeah, 500 by 500 or 400 actually no, yeah, I think it was like either 400 or 500 cubed. So very very large printer, and heating up that bed to 80 to 100 Celsius would easily double the environment inside compared to outside of the enclosure. And then it has this little window to see inside. But this is just an example. They sell a whole bunch of different ones of these. Also, you can do a more elaborate enclosure, but it doesn't need to be that elaborate. This right here is pretty good. And the reason why this works is that in heat transfer, you have difference in temperatures, linear difference in temperatures. So the difference in the surface temperature versus the difference in the environment temperature, right? And the closer that these get, the closer that, because it's a multiplier, right? It's like T2, which you could say environment, minus T1, right? And the closer those get, it's multiplied by how much energy it loses within an amount of time, which is power, wattage, same thing as electricity. So the closer those get, the less heat you lose. So once those equal zero, right? Obviously you have zero heat loss. So the closer those get, the hotter that part stays and the less warping you have. And it's a linear relationship. So if you say, if you cut it in half, if you cut the distance between the part temperature and your environment temperature, if you cut that in half, it will, which is basically you have the part be twice as close to the bed temperature as it was before, you can get you have half the heat loss, and thus it will lower your warping by half. And that could, just that lowering the warping in half could allow for enough holding force from your bed to prevent warping at all. So just a simple enclosure like this can drastically increase your performance on those higher end materials. Now, the higher and higher end you go, the more and more things you need to do. So also the other option is to add is to add a heater. But one of the things, add a heater inside that controls the temperature and increases it even higher than what the bed can do, just the passive heating from the bed. But I would start out with the passive heating from the bed, because what you do have to look out for is in this, you could actually overheat your printer as far as your stepper motors can get too hot, and then you start to skip steps, especially on your extruder and your X and Y axis, especially if they're not attached to an aluminum frame such as the Ender 3 with an aluminum bracket. So make sure that you have a way to get your heat away from your stepper motors, right? So for example, on the Prusa, they have 3D printed parts that hold the stepper motors. That's going to trap the heat in the stepper motors and possibly cause skip steps and failed prints. So watch out for that. So these are pretty cheap. I think they're like $50 at the max, and they may even provide a little bit of flame retardedness if something were to go sideways inside. And so to be able to drastically increase the temperature and lower warping by as much as half, or not completely eliminate it on these lower middle range materials, is pretty beneficial. Also, because you have less heat loss, you require less power. That will cut your power usage in half, right? And obviously, it takes a while for this guy to heat up, and then you will start to see the benefits, right? And then anything better than this, you'll see more and more and more benefits, but to a point, eventually you'll have diminishing returns. Another thing is to also make sure that whatever room that this guy is in is hot. The room around the enclosure is hot, as well as there is no fan running around the enclosure. There's no moving air, it's just stagnant air. So those are also two ways that you can increase your printing performance on these higher end materials. All right, so that's it. Very simple enclosure. Increase your performance, increase your quality, etc., etc. Increase your success rate as well. All right, guys, if you like this video, please go ahead and subscribe for more tips and tricks. If you guys did not know, I teach Udemy classes on beginner 3D printing and also in intermediate 3D printing. This is a subject for my my upcoming intermediate 3D printing class that has not been released yet. And so if you would like my teaching style and you want to have more content and learn more about FDM 3D printing, go ahead and check out the links in the description, and I'll see you guys in the next tips and tricks later.